Hey, today I'd like to explain what Git LFS is, uh, and yeah, to help you manage large files in your Git repositories. So what Git LFS stands for is just large file storage, and I use it to store like any kind of binary files or large files. And why you want to do that and why you need a Git add-on for that is because Git is made to store text files, and so if you create a store big binary files in Git and then modify them, it will store the diff, and then your repository history will grow and grow in size, and at some point it will take a really long time to clone. So here you can see I have a demo repo, git init, and I have a 1 megabyte binary file in it. I mean, kinda 1 megabyte, and we're gonna add it with git LFS. And what you want to do after initializing your repository is git LFS install. And I forgot to add to install git LFS. It's not built into Git. You have to install it. On most Linux system, it's like whatever your package manager, and then the package is named git-lfs, like pacman. For me, it was git-lfs. I think on Ubuntu and Debian it's the same. And for Windows, switch to Linux. Then what you want to do after git lfs install, you want to do git lfs track like this, which will tell git lfs which files, which file names actually designate binary files or like large files that you want to in git lfs. This will modify the git attributes file, which will say for those kinds of file, use LFS. And next, yeah, that's it. Now you just git add like you usually do, and then maybe I should show that for now the size of the repository is 1.2 meg, and then git commit that, and now you can see that here still 1.2 meg. But if I modify it, how did I modify it? I did a tr last time, yes. If I modify the file, alright, there was no space in it. Let's say modify, I don't know, R, is there an R in it? Yes, there was an R in it. So I modified the binary file. And now if I commit, up, yeah, so on the local repo, it will have doubled in size, or it should have. Yes, it was 1.2 meg and before, and now I added so now there is two versions of the binary file on your local machine. And now you're like, oh wait, I still have the two versions, that's useless. But the interesting part is when you push that to a remote. So let's say remote add, I already created the repository for that. And then push, and let's push all that to a repository, and I might actually just show you. And you can see there is some LFS specific stuff to upload the LFS files. And here, you can see in my test repo, I have the binary files, and if you go on the binary files, if you click on it, you can see that it has this store with git LFS thing. So your remote repository like GitHub, GitLab has to support LFS. Luckily, most of them do. So that's handy, but you have to know that. And so now if I just cd and then clone like this, remember the one on my local machine was 2 megabytes since it stored the two versions, but here if I clone into T, and go into T and then sh git. It's only 1.2 megabytes because it only downloaded the latest version of the binary files. But the way git LFS works is with a cache. So if you need the binary files, it's gonna download it. So if you check out a new branch where there is a new version of the binary file, when you check out, it's gonna download it. Or like when you, I don't know, I haven't tested this, but maybe if I go here, it will actually git checkout and then an older commit where the previous version of the binary file was. Should see that now the git repository is 2 megabytes because it just downloaded from GitHub the other versions. So it's like lazy in a way. And that's how you save download time if you have large files in your repository. A few things I forgot to mention maybe is that you can do git lfs ls files to just list the files that are tracked by git lfs. And one more thing is you may wonder, like, how does this work if the guy that clones my repo doesn't support git lfs? And that I can show you with this option. So here, just git clone like this, but I add this. And so this environment variable will tell git lfs to just not download the binary files. And let's put it in T2. cd T2. And so now we should have a very small repo. Yeah, as you can see, it's like 200K. So it didn't download the binary file. And now the interesting part is you can see how git lfs stores under the hood the binary files. And so you can see it stores them as just text files with a specific ID and a size. And that means that from the Git perspective, your binary files and large files are only text files, but then LFS does some magic when you check out or fetch or clone, so that those pointers to file, this is a pointer I mean, are replaced by the actual binary files. I added this environment variable here, but if the guy didn't install git lfs, it would be the same result where he would have those pointer files, but not the actual binary files. And so it's still kind of compatible. This was actually really useful for me in CI/CD, where I needed big files to build the Docker image, but I didn't want those big files when I did some unit testing or formatting. And so with that option, the test jobs took actually a lot less time, and the big files were downloaded only when needed. And yeah, that's pretty much it. I hope it can help you not have a 2 terabyte Git repository in the future, and have fun. See you.